Hello and welcome to this first part of the tutorial Blender for Physics. I'm Timothy Mawsome, and in this first part I'm going to show you how to install the latest version of Blender, familiarize you a bit with some of the basic tools, and we're going to do a quick exercise of building the simple cubic cell that you can see in this picture. So hopefully this will give you a starting point where you can start to familiarize yourself with the abilities of Blender and get to know the workspace. And from then, in subsequent episodes, I'm going to build on this really simple framework and show you how to build more complicated representations of solid-state systems, experiment with different features of Blender, and make a variety of different figures that can be useful to scientists. A little bit of housekeeping first. So I am not a professional 3D artist by any means. I'm a condensed matter physicist. This is not a Blender tutorial series for 3D artists. That means that I'm not going to be covering quite a few of the tools that are really the bread and butter of 3D modeling, things like the sculpting tools. If you're looking for a more general tutorial about Blender, there are many on YouTube already. This is specifically about using Blender for scientific figures, and so I'm going to spend a lot of time on some quite esoteric tools that most 3D artists would never use. Another aspect of me not being a professional 3D artist is that most of the knowledge I have here has been gained through experimentation. There may well be better ways of doing some of the things I'm going to show you that are perhaps more industry standard. If you know what those are, or, if you have alternate ways of approaching these things that would be more efficient, that's fantastic. If you want to share those in the comments so everyone can see them, that's brilliant. But yeah, don't be surprised if some of the things I'm going to show you are hacks or workarounds, because as I say, I'm not a professional 3D artist. That being said, when I've used Blender in conference presentations and in lectures to create animations and 3D models, I have generally found that people have found those figures to be impressive and engaging and attention-catching, and a lot of people have asked me how I make them, which is why I'm doing this. So if you've seen some of my figures on Twitter, for example, and you're interested in how I make them, this is exactly the right place to be. If you're an experienced 3D artist or someone who's looking for 3D modeling expertise from a professional source, this is not the right place. Okay, so with that out of the way, let's jump into the actual tutorial. Okay, so the first thing that you're going to need to do is download the latest version of Blender. So for that, just type Blender into your preferred search engine, and hopefully the first thing on the list will be blender.org. If you just go to the front page of this website, you'll find a download option for Blender 2.91, which is the current version. Now, Blender has been updating more and more frequently as of late. In general, all the core features stay the same between updates, but do bear in mind that if you're coming to this tutorial several months after it's been uploaded, some of the core features may have changed. Okay, I will try as far as possible, if there are changes through the cycle of this tutorial, to make update notes so that you can see what's changed. But hopefully it won't impact anything that's hugely relevant to what I'm going to cover. So just click to download Blender 2.91, pick your correct operating system, and you will end up with an MSI file, which you can simply save, and then run this to install Blender. You'll get a setup wizard. My wizard will look slightly different to yours because I already have Blender installed. So you will not see the change or repair options, you'll just see the installation options. And finally, once you've gone through those options, you can just start the installation. And then finish, and that's it, you now have Blender installed. When you boot up Blender for the first time, you will see this. In the middle of the screen here is a little flashcard. This gives you the option to open new files of different types. Throughout this entire tutorial series, we're only going to be using the general type. That is the basic format for 3D modeling projects. You also have the option to open previous projects and a recovery option so you can recover the last session. Blender features an auto-saving feature, so your projects will be backed up when you quit, or if you crash, they can sometimes be backed up. I found that the autosave is not hugely reliable, so don't rely on it to save your work. You also will have a list of your recent files, and here you have the option to access some online tutorials and release notes that are provided by Blender. Those are sort of more like a scripting API. They're quite detailed and they require a certain amount of beginner knowledge before you can really understand them, hence why there are so many tutorials around. And of course you have a donate option so that you can support Blender if you so wish. For now, we'll just click off this to get rid of this window, and now we're faced with the typical start scene for a Blender project. Okay, so I'm very briefly now just going to run down some of the components of this main workspace and what they mean. I'm not going to run through all of the tools in detail because there are a huge number of tools in Blender, and they all have quite specific functions, so it would take me several hours to go through all of them in detail. So this is going to be a very broad overview of the workspace, and basically we're going to learn how to operate Blender by doing modeling projects, and I will introduce each tool that I use in those projects in more detail at the right time. That way you can actually be doing something while you're learning how to use the system, rather than having to just listen to me drone on and explain it for hours. But we do need to be able to orientate ourselves in this workspace. So right in the middle here, this is your 3D viewport. This is the main area where you're going to be working when you're doing 3D projects in Blender. Okay, so this shows you the world in which your objects exist, the scene in which your objects exist. And we have a few things here to help us navigate. The red and green lines represent the X and Y axis of the world space. Optionally, we could also put the Z axis in here. So what I'm going to do now quickly, I'm just going to turn on screencasting. This is a mod, so it won't be, you won't find it in your default Blender package. But what this means is that when I press keys, you can see what I'm pressing appearing in the bottom left-hand corner. And the grid, the gray grid here, represents the Z equals 0 plane, and the grid spacing here is 1 meter, so this gives us an idea of scale. In the center of this view, we have this yellow dot. This marks the center of the object we have selected, which in this case is the cube, and you can see it's selected because it's outlined in yellow. In the same spot as that yellow dot, we have the 3D cursor, which is this red and white ring. This is a reference point that we can place in 3D space. It's not hugely important. I'm not going to discuss all the functions it's relevant to right now, but you can use it in certain cases as a reference point. The default object that's placed into any new Blender project is a single cube in the center here. There are a few other default objects that appear in the scene. This is the default camera, and this circle up here is the default light source. So when we render a scene in Blender, there are a couple of different rendering engines we can use, but essentially all of them involve some kind of ray tracing. So when we actually render this scene into an image, what's going to happen is that rays will be emitted from the light source. They will interact with the objects that are in our scene, and then they'll be collected in some camera object which is viewing the scene. So the actual view that we're looking through here into the 3D viewport, this has nothing to do with the final image that we'll get out of this project. That is determined by the camera and the light source. This is just a convenient way of viewing everything that's in the scene so that we can model it and arrange it where we want. Okay, the first thing that we need to know is how to navigate around this 3D space. So in order to rotate the camera, simply hold down the middle mouse button and move the mouse to spin the camera. Now you'll notice that here we're rotating around the cube, which is in the center. This is because by default, the pivot point for the camera is the origin of the world space, 0, 0, 0, and that's also the default position for the cube object to be placed. We don't necessarily always want to be pivoting around the origin of the world space, so we can change where the pivot point is in a couple of different ways. The first one is to move the pivot point manually, and to do this you hold down Shift on the keyboard, then press and hold the middle mouse button and drag the mouse. And you'll see that this moves the camera laterally around the world space. So what we're doing here is we're dragging our pivot point around the plane that's created by the normal of the camera and that intersects the pivot point. Okay, so we can move our viewpoint anywhere around on that plane, and then if we release Shift and then we hold down middle mouse again, you'll see we're now rotating around a different point in space. What you'll realize though is that the new pivot point isn't actually marked in the world space, and this can easily get very confusing, so it's important to have an easy way of going back to a reference object. So to do this, just select any object in the scene, for example the cube, and then hit full stop or delete on your numpad, and you will snap back to that pivot point. So now we're pivoting around this cube again. And we can snap to any object that we can select in the scene. So for example, we could snap to the camera in the same way, or snap to the light source. Zooming in and out, which I've been doing a bit without telling you how to do it, you just scroll the middle mouse wheel in and out, and then you can zoom in and out of any object. You're zooming relative again to that pivot point, so you'll never actually be able to go through the pivot point. But yeah, you can zoom in and out with reference to that pivot. So that briefly covers how to move your viewpoint around in the world space. But what about moving the objects themselves? Well, there are a couple of different tools for doing this. They are all accessible from the object menu, but almost all the time you're going to actually be using shortcuts to do this. So the first thing is just to be able to physically move the object around in the scene. The shortcut for this is to press G, and then if we drag the camera, we can move the object around. But of course, we're trying to translate a 2D motion into 3D space, and this is not always very intuitive, and it's sometimes difficult to get the object positioned exactly where we want. If you find that you've done a movement and you're not happy with it, and you just want to return that object to where it was, then simply right-click, and the object will snap back to where it was, and the movement will be cancelled. We can move an object on each axis individually if we like to get more precise movement. So to do this, press G and then press the letter corresponding to the axis in which you want it to move. So for example, G and X will allow me to move along the x-axis, Y will allow me to move on the y-axis, and Z along the z-axis. And you'll notice that each time I'm pressing a new axis, the previous movement is cancelled. So this is useful because this translation, this is just like a test translation. It's not actually applied until you left click. And then the actual transformation is applied to the object and it's moved to that position. If for whatever reason you find you've moved an object and you don't like that, you can undo in the normal way just by pressing Ctrl Z, and it will undo the last transformation. If you wanted to, you could also access these move commands by going to this left-hand menu and clicking on move. That would bring up this widget which sits in the scene, and we can simply click and drag the arrows on this widget to apply transformations. That can be useful, but personally I see no reason not to just use the shortcuts because it's much quicker. Right, go back to normal select. If you want to move an object on a plane rather than on an axis, that is also possible. If you press G and then press Shift and then the axis you want to exclude, you'll move in the plane formed by the remaining two axes. So if I press Shift X, then I can move in every axis except the x-axis. If I press G Shift Z, then I can move in every axis except the z-axis. So that can be useful if you're trying to move objects around on a surface, for example. Okay, what about rotation? Well, rotation predictably is accessed with the shortcut R. So this again allows me to rotate in the plane formed by the camera. So limited use free rotate. And again, I can choose to rotate around any axis in the scene just by pressing the relevant axis, and then I'm locked into that specific axis. And I can of course cancel that rotation at any time by right clicking, or I can set the rotation by left clicking, and I can undo it with Ctrl Z. If you wanted to, there is also a widget that can do this, which is the rotate on the left hand menu here, and then we can drag a specific rotation axis. And finally, we have scale. So this will resize an object. The shortcut for this is S. If you press S, then you can simply drag the object to be bigger or smaller in the scene. And again, we can select specific axes in which to change its size, or we can select a plane in which to change its size. And undo by right-clicking the mouse, or rather, don't set that by clicking the mouse. And there's a widget again, which is represented by these square terminated lines, which you can use if you so wish. Okay, so that defines how to manipulate objects in the scene. Whenever we're applying any of these different transformations, what we're actually doing is changing the transform of the object, which is listed in this menu on the right-hand side of the screen. This is called the N menu, usually in literature, because you can pull it in and out using N on your keyboard. The first and most obvious component of the transform is its location in space. So you can see that if I select my object, press G to move, press X to move it along an axis, and then set it by left-clicking, the X position has now updated in this field. But I can also simply update this by entering values into these fields. So I can press 0 in here and enter, and it will move it back to X equals 0. It's also possible to click and hold to left click and hold in any of these and drag this value up and down to wherever you wish, or you can just simply enter whatever value you want, or indeed you can also perform basic maths. Any maths that would be permissible in basic Python can be done in any of these fields. So if I was to say 1 plus 2 plus 3 and hit enter, it moves it to 6. Okay, and I'll reset that back to 0. You can optionally lock any of these transforms to prevent them from being changed accidentally in your scene. So if you're doing lots of different transformations and you don't want to accidentally move an object out of position, you can lock it in place so that it can't be changed. The rotation is exactly the same. It works in the same way. So we can drag different positions, or we can enter them manually. If you want to move quickly between different parameters, if you want to move down through a set, for example, you can press Tab to simply enter the value that you've just written in that field and move to the next one. So if I press 0 and Tab, it sets that value and immediately allows me to edit the next. So I can resize my object by hitting S and dragging the size, and you can see that that is changing both the scale and the dimensions. I can undo with Ctrl Z, or I can just unset by right-clicking and it will go back to its original size, or indeed I can enter values into here and drag them manually or type my values in. Okay, so that's the real basics of how to transform objects in a scene. So there are two more windows that I'm going to introduce to you now. There are two more menus I'm going to introduce to you now. The first is the hierarchy of the scene. Okay, so this shows you all of the different objects that are in this scene, and it shows you the collections that those objects are part of. So in Blender, all objects are grouped into collections. By default, in any scene, you have one overarching collection that contains every object that's in the scene, and then we have any number of sub-collections. By default, you'll have one additional collection in the scene that contains the default objects. Most of the time you won't be interacting with the hierarchy, but sometimes you will need to select objects from it, and when we come to some more advanced features of Blender, you will need to know that all of the objects in your scene are being stored in this hierarchy. The final menu is the Properties menu, which is at the bottom right here. There are a large number of different tabs in this menu that allow you to change different things about how Blender works. I'm not going to go through each tab individually. Instead, as we work through projects, we will slowly come across the different functions that are contained in these tabs, and I'll explain them as I go. But very briefly, the top here is the Tools menu. So this refers to the different tools that you've selected from this left-hand menu. Most of the time you won't use this because you'll be accessing tools through shortcuts. The next block of menus, so starting from the camera and going down to the world, these are parameters that affect the render, so the final image or animation that we're outputting, and we can control different aspects of the rendering process through these 5 tabs. The next 4 tabs refer only to the selected object. Okay, so these are contextual tools. At the top here, the orange square, these are the basic properties of your object, such as its transform and its relationship with other objects in the scene. We have a physics tab. Blender is not much of a physics simulation tool, but you can do some very basic simulation in it, and this is where you would put physics into your scene if you wanted it. You can also add constraints to objects. This is mostly relevant to animations. And then you'll have a couple of different contextual menus. At the moment we have the light selected, so we have different properties of the light that we can modify. If I were to select the cube instead, then here we would have properties of the mesh that we could edit instead. And the last tab here is the material. So any object that can be rendered in the scene can have a material attached to it that will modify how it interacts with the lighting engine. And the very final tab, all on its own, is the texturing context menu, which we're not going to worry about for now. Basically, you can use it to add different texture maps to objects. We'll worry about that at a later date. Okay, so with that, you hopefully now have some understanding of how to navigate your workspace and how to move around in it and what some of these different menus mean. So that's already taken quite a long time. So I'm going to jump right ahead and start on a modeling project. So the first thing I'm going to do is I'm going to clear the scene. So I'm just going to select each object in turn and delete it. Okay, normally you don't necessarily need to do that, but to show you how to build a project up from scratch, it's useful to have a completely blank project. Okay, so now all we have left are the scene collection and the one sub-collection into which our objects are going to be entered. So in order to add an object to the scene, you need to press Shift-A on your keyboard. This brings up an Add menu, and you can see there's a huge number of different objects that we can add. Almost all of the renderable objects that can go into the scene will be defined as meshes of different kinds. So the mesh is just a set of points in space that are used to describe the object. Okay, so for this initial test, we're going to be making a simple cubic cell. So the obvious place to start for that is to put a cube into the project. Okay, so now we have our default cube back. When you enter a new mesh into your project, you will get an Add menu, which will pop up in the bottom left. And this will allow you to edit certain parameters of the object initially before it's actually entered into the scene. So here, for example, we can set the default size of the object, we can move around where it's going to spawn in the world, or we can change its rotation however we like, or we can change how it will align. So we could, for example, spawn it in the center of the view if we were way away from the world center, and we didn't want the object to appear at 0, 0, then we could align it to our camera view or to the 3D cursor if we were using that instead. But for now, we're just going to use the default one. So I'm pressing 0 in tab as I go down here just to reset everything. Okay, so if we click off this, if we left click away from the cube, then it will be added into the world. And you can see here that the cube has been added into the scene collection. We want to drag and drop this so that it becomes part of this sub collection. And we're going to rename this as objects. Okay, it's good practice to make sure that your hierarchy is well labeled and that you've separated things out into contextual collections. In a project where you only have a handful of objects, it might not seem important, but it's good to get into the habit, because if you're working in a scene where you have hundreds of objects, it's going to become important very quickly. Otherwise, you're going to be searching through these piles of unclassified objects, trying to find the one that you want to edit. Okay, now we have a cube. But there's a problem here, because the way we're viewing this cube at the moment, it appears as a solid object. Okay. The way that we're viewing this cube at the moment is in a view mode called solid mode. And different view modes can be accessed from this array of spheres here on the top right. These represent different render modes. So solid mode is basically a really simple grayscale representation of the object, where it has some shading that's applied to different faces based on the angle of the camera. And it's basically just there so that you can identify the objects in your scene. If we wanted to break this object down just into its component vertices, then we can click on the wire mesh mode, and then it will remove that grayscale imaging and we'll just see the physical dimensions of the object in space. Another possible mode is viewport shading, material mode. This is basically for testing out how different materials appear. It projects an image onto the material to show you how it would interact with a complex scene. It can be useful, but I basically never use it. And finally, we have the actual rendering mode. So by clicking on this sphere on fourth along to the right, we go into using the actual rendering engine to see how the scene would look in the final render. Now, at the moment, this cube looks like a completely dark grey. That's because the only light that's actually reaching it in the scene is coming from the background, which, as you can see here, is dark grey. You can edit this background by going to the World Properties tab in the Properties menu, and here you can see that the first option here is Surface, and we have a colour and a strength. Basically, the background, the world background, is a surface that's emitting uniform light into the scene, okay, of a specific colour. So at the moment it's emitting this dark grey, but we could, for example, turn this into white and then our scene goes white. In general, we use dark grey because it's really easy to see different objects contrasting against a dark grey background. We could also change the strength of the light output. It will, of course, if we make the light very bright, it will go white, because if the light is strong enough, even if it's gray, if it's grayscale, it can't have color. But we'll stick this at 1 because it's easier. Okay, so at the moment there's not really any point in trying to render our object, but we can see that there is this full cube that exists in our world, and we don't actually want that. In order to create our simple cubic lattice model, what we want are atoms at the corners of our cube, but we don't want the cube itself to be rendered. So the reason this is rendering is because it has faces. Okay, so in order to describe how this works, I need to show you how meshes are actually represented in Blender. So at the moment we're viewing this object in what's called object mode, and this is identified by this drop-down menu in the top left. So in this mode we select and manipulate whole meshes, whole contiguous objects that are identified in our hierarchy here. Okay, but each object is actually a mesh of all of these different points in space. So if we want to view the mesh, then we press Tab while we're in object mode, and you can see here we've changed to edit mode, or you can simply select different modes from the drop-down menu. Now in edit mode, we can see the full mesh of our object. So at the corners here, we have vertices, which are defined by these points. So those are the coordinates of the object in space. And we can tell whether vertices are connected or not because they will have edges that run between them, which are represented by these lines. Okay, in order to select different components of the mesh, you can change your selection mode while in edit mode by clicking on these icons next to the mode drop-down menu. So vertex mode is the dot on the cube, edge mode is the line on the cube, and then face mode is the square, the plane on the cube. So those edges, these lines that join the vertices, together they define a face. And a face can be filled or it can be empty. So if I move to face mode, you can see that we can select all of the faces on the different sides of the cube individually. And the reason the cube is showing up in our render is because all of these faces are filled, so they interact with the lighting engine. So we want to get rid of all these faces. And in order to do that, while we're in face mode, we simply press A on the keyboard to select all, and now you can see all of these faces are highlighted. In order to delete the faces, press X and you'll get a contextual delete menu. Now we can delete different aspects of the mesh. We can delete vertices, edges, or faces. If I were to select faces now, the entire object would disappear. You note that the object is still registering in the hierarchy because the object is still saved in the hierarchy as an individual object, but it now has no mesh associated with it. There's nothing there. You can see if I go back to vertices and I try to select, there's no vertices left. Okay, that's because whatever mode you're in, whatever component you're deleting, it's deleting the vertices associated with that component. The edges and the faces don't actually exist as independent objects. They're just references to vertices in the mesh. Okay, so this is not what I want to do. So Control Z to bring it back. What I actually want to do is delete the faces, but leave the edges and the vertices untouched. So if I press X again, you'll see I also have the option of only edges and faces or only faces. So if I click only edges and faces, then I'm left with just the vertices floating in space with no connections between them. Okay, now this might work, but actually something I want to do with this simple cubic lattice will involve using the edges. So I'm going to undo this, and I'm actually going to delete only faces. And now you can see I have what looks like a wireframe model. I just have the vertices and the edges joining them together. Okay, and this is what I actually want. So now we can press Tab to go back into object mode, and now you can see if we go to the render preview, there is now only the wireframe model. There's no object, there are no rendered faces here. And if I were to actually render this scene now, I would see nothing there, okay, which is what we want. Okay, so now what I want to do is add my atoms to the corners. So for the atoms, we're going to use a sphere. So again, press Shift A and you'll get an add menu. And you'll see there are two different types of sphere meshes that we can create. One is called a UV sphere. And this kind of looks like a map of the world, right? We have longitude and latitude lines, and all of the lines converge to points at the poles. Now, the reason it's called a UV sphere is because this is a sphere that's designed for a process called UV unwrapping, which is basically how we project images or textures onto 3D objects. But the UV unwrapping is not something we're using here, and this type of sphere, the way that it's defined mathematically and the way it interacts with the lighting engine can cause a lot of problems, because where we have these singularities where all these vertices are coming together, that can play havoc with the lighting engine and make it behave in really weird ways. So we don't actually want a UV sphere, so I'm going to get rid of that. And instead, I'm going to put an icosphere in. So an icosphere takes the sphere and it breaks it down into a polyhedron that's defined by triangles. And this is much easier to control in terms of how it interacts with the lighting engine. So we're going to go for this. Now, in the initial adding menu here, you'll notice we have a couple of new options, including this one called Subdivisions. Subdivisions allow us to change the number of triangles that define our polyhedron. So if I push this up and up and up, you can see I get more and more triangles until I can actually not see the triangles at all anymore, and it looks like a perfect sphere. Now I could do this in order to make these perfectly spherical, but actually I'm not going to do it through the Add menu because it'll enable me to show you more things. So we're going to keep this at 2. And I can also change the size here. Obviously, I can change the size of the object using the scale function after I've added it into the scene, but just for the sake of convenience, I'm going to modify the scale before I actually confirm I want to add it, and I'm going to make it not 0.1, 0.2 meters in size. 0.3. So, 0.5. That'll do. Okay, I like that. And of course I can change its size. You'll see this thing here which says generate UVs is ticked. Don't worry about that. What that's doing is it's creating this 3D to 2D map for texturing purposes. You can leave that ticked and it doesn't matter. Okay, so we add that to the scene, and now you can see we have an icosphere in our objects collection. Okay, this is because we had the objects collection selected when we created the new object, so it was added to the same collection. Okay, so this is going to be our atom. Now, of course, what I could do now is simply select this object with the left mouse, go to location and type 1, 1, 1, and then it would be at a corner, and then I could create another icosphere, and I could say 1, minus 1, 1, and it would be added to the next corner, and do that 8 times. But that's kind of boring and laborious, and while that might be possible for a scene where I'm just going to have 8 objects, if I were making a whole massive lattice and I had 10,000 objects, that's going to be sort of a couple of years of my life just placing spheres in my scene, so obviously that's not going to work. What we're going to do instead is we're going to use this initial object as a reference and create 8 instances of this object which exist at predefined points that are given to us by the cube. Okay, so the way that we're going to do that is using a tool in Blender which generates hair. Okay, so Blender was initially designed for 3D animation, and one of the most difficult things to do in 3D animation is hair. Okay, because we've got thousands, or in my case, slightly fewer, strands coming out of the head, and we can't model each hair individually. That's insane. So instead what we do is we create a single hair as a reference object, and then we create thousands of instances of it and map them onto a mesh that defines the head. We can use exactly the same engine, the same code that creates that hair, and we can use it to create arrays of any object that we like. Okay, so the hair object is what's called a particle instance. Okay, so it's where you're using a particle instance is any time where you're creating large numbers of objects that are all based on the same reference. And the particle instance isn't added to the sphere, it's added to the object that's creating the geometry, which in this case is the cube. So if we select the cube in object mode, okay, so it's outlined in yellow, so it's selected, then we go to the context menu and we go to this sort of branching thing. This is our particle properties. Okay, so click on that. You'll notice that at the moment we have no particle properties attached to the cube. To create a new particle instance, click plus, and you'll get a particle settings context menu. By default, the particle settings is set to an emitter. So this is something that's going to act as an origin point for particles to come out, like smoke or sparks or something. We don't want that. We want them to be anchored to the mesh. So we're going to use the hair option instead. Regrow, that's only relevant in animations. Don't worry about that. The one that but we do want to click advanced. This is going to give us a couple more options that we wouldn't have otherwise that we might need to use. Okay, now we have this menu called emission. Even though we're using this as a hair object, it's still referred to as emission. This allows us to define some basic properties of the particle collection as a whole, such as the total number of particles. By default, it's set to 1,000. Again, this is supposed to be used to model hair, so it's assuming you have a large number of objects. We only want 8. The seed, so this is where you are in a random number table. We're not generating anything randomly here. We're generating things in a specified order, so we don't need a seed. Hair length, so by default, it's assuming that you're going to put in paths that are going to act as your hair strands, and so it's allowing you to change the scale of those hair strands to fit whatever model you're applying it to. If you want to just have a 1-to-1 scale from your original object to the final object, you want that to be 1. And segments we don't need to worry about because we're not actually defining hair, so we don't need it to flex. Okay, the next drop-down menu is source. So this tells you where your hair is being emitted from on your object. At the moment it's set to faces. We don't have any faces in our mesh. So instead, click this and then click vertices. And now you'll see that we have some random bits of hair sticking out of the corner of our cube, which is a bit weird. But we're going to replace those. We're not going to leave them as hair. Hair dynamics, don't worry about. Velocity, rotation, these are all things that are more relevant to animation. Physics, so you can make these objects have some physical properties, such as mass. But we're not going to animate this, so we don't need that. The thing that we need is render, okay? This defines what these objects are going to be and how they're placed in the scene. At the moment, the hair is rendered as a path. So if you're defining a hair strand, you just say it's a path from a position in X to another position in X, and that creates a line. What we want is to render them as objects. Okay, and you see when you select object, you then get this object context menu with an empty field called instance object. So that is the basic object that we're going to create instances of. To fill that, simply go to your hierarchy, click and then drag icosphere down into that field. And now you see we have tiny, tiny little spheres at each corner. They're tiny, tiny because by default the scale is set to 1/20th of the original size. So just go to that scale field, enter 1, enter, and now they're the same size as the original, which is what we wanted. But you'll see that there are some positions missing, which is odd because we told it we wanted 8 objects, so there should be 1 on every corner. One of the things about this method of generating multiple objects is that when animators are creating hair, they place the hairs randomly on the head. So even when you're telling it to generate these objects from vertices, it's assigning a vertex at random. So in 2 cases here, it's assigned 2 spheres to the same vertex. We can stop this if we untick random order. Now it assigns a sphere to each vertex in order through the entire mesh. Okay, so now we have a sphere at every corner just as we wanted. But we have an issue here because the center sphere is still visible. That might be fine if we wanted a body-centered cubic lattice, although this is actually a separate object in space to the rest of our lattice, which is not that convenient. So this is where it's important to use collections correctly, because what we're going to do is take that center object and put it into a separate collection that we're then going to hide. So in the context menu, right-click and click New Collection from the drop-down menu. We're going to call this new collection Originals. Okay, to store the original objects, and then we're going to click this icosphere and drag it into Originals. And now what I can do is I have a tick here, so that allows me to exclude this collection from the viewable layer. So if I untick that, that sphere disappears, but all of my spheres on the corner remain because they're in a different layer. Okay, so now I have my simple cubic lattice. Great, all done. No, not really, because, yeah, okay, technically we've got the right geometry, but this looks like some sort of very early NES game. It's very polygony, it's very rough. Okay, so how do we improve the appearance of these atoms? Well, the reason it looks so blocky is because all of the geometry is defined based on a limited number of points. So when light is interacting with an object in Blender, it's coming down and hitting a face, and then Blender is calculating the reflection angle from that face. So if the face is completely flat in the scene, then it will have the same contrast over the entirety of the face, and you'll get this really blocky looking texture. Now we can change that by adding loads more vertices to our mesh so that it's fine enough that we can't see the individual triangles. But in order to create enough triangles in the scene that, or attached to an object rather, so that you couldn't actually see the blocky texture at all, we would have to have thousands and thousands of vertices, and especially if we have lots of objects in the scene, we'd very quickly run out of memory. So here we can do a trick where what we can say is where you have one of these vertices between two planes that's at an angle like this, rather than calculating the reflection angle of a beam of light based on the actual angle of the faces, you can average over between those two, so you artificially smooth the face that the light is seeing, okay, even though you still have limited geometry. If we try to modify these atoms directly, we won't be able to do anything because these are just instances of the object that we put into the originals collection. So if we tick this collection and bring the original atom back, we can select this object and then right click on it, and we get an object context menu. And you'll see the first two options here are shade smooth and shade flat. If you click shade smooth, you'll see that the surface now looks smooth. It looks like a round surface. Okay, change back by clicking shade flat. Okay, that now looks a bit better, but you'll notice around the edge here, we still have these blocky vertices. That's because the shade smooth option is only affecting rays of light that are actually interacting with the object. So if an object misses one of the faces entirely and goes past it, it's not affected by that shade smooth function. So we're seeing the raw geometry of the edge. So here there is really no way around this other than to actually modify this geometry. Okay, so obviously we could have done this in the add menu by changing that subdivisions number, but we can do this after the fact by adding a modifier. Okay, so modifiers are added using this wrench menu. So click on that and you'll see there's a drop down menu here called add modifier. If you click on that, you'll see there's a huge number of different modifiers that you can add to objects in Blender. I know how to use about a third, maybe half of all of these. Most of them are very, very specific and only do very specific things. Some of them are extremely general. Probably the most common will be subdivision surface. That's the one that you'll be using in almost every Blender project you do for things like this, where you need to redefine geometry, where you've introduced something that has simple geometry to get started, and then you need to make it complex later on. So select subdivision surface, and you can see immediately on adding this modifier it looks a million times better. We've still got a slightly jagged edge, but you know, if you move a decent enough distance away, it looks completely round. So what this is doing is it's taking the original mesh and it's just cutting it up into smaller and smaller triangles. And we can change how many triangles we're dividing this into by changing these values here. The reason we have two different options for the number of subdivisions is because sometimes you want an object to be simple in the 3D viewport so that you can, view it and manipulate it easily. But in the final render, you want it to be more complicated. But in this case, we want both of these to be the same. So we're going to put both of them to 2 and then have a look at the edge. And I'm pretty happy with that. I think that looks round enough to the eye that you can be fooled. I don't think we need to add any more subdivisions. If you want to add more, go ahead, but do be wary. If you start going past 8 or more subdivisions, you will start to find you get a lot of slowdown because it takes up a lot of RAM. Now, there's two options here at the top. One, Catmull Clark, which is highlighted, and the other simple. If you click simple, you'll notice that we get this kind of blocky geometry back. That's because when you're doing a subdivision in simple mode, it doesn't try to average the position of the new vertices. It just adds vertices to the existing geometry. Whereas when you use the Catmull Clark smoothing method, it averages over the surface so that you get a nice smooth shape rather than just adding vertices onto the original geometry. There are some advanced methods that we can use as well, but I wouldn't worry too much. We're not going to bother about those right now. Okay, so now we have some nice round looking atoms. Are we done now? Well, maybe, but the problem is that these atoms, while they're the right shape, they still look kind of grey and boring. And if we went to the render, which remember is what this scene will look like in the final image, it's, you know, this is no good, is it? We can't see anything. So the next thing that we need to do is sort out the lighting and materials to make these objects look good. Okay, so let's go back to object mode, to solid mode rather. And we're now going to add a light source into the scene. Again, hit Shift A, and you'll see that one of the options for the types of objects we can add are light sources. And we have 4 different types. A point source. If you're a physicist, you don't need me to tell you what a point source is. The sun source is just fully collimated and covers an infinite area. So it mimics the sun in that respect. The spotlight is very much like the point source, except it's confined to a specific area. And the area light means that you have an area source rather than a point source. And so you get averages of all of the different ray directions from the different points on the surface area. We're going to use the sun type because it's the easiest really to use, and in my opinion makes things look the best. Okay, so we've put a sun light source. We can't see it right now because it's on the origin and we already have a sphere there. If you want to see objects that are layered on top of each other, you can go into something called X-ray mode. To do this, press Alt-Z, and you'll see that these objects have now become translucent and we can see through them. You can also do this by clicking on this icon in the top right here. That will toggle you between X-ray mode or solid mode. Okay, so now we can see where the light source is at the center of this object. It is selected because it's highlighted in orange, so to move it, we just press GZ and we can move it up. Now, in terms of lighting, it doesn't actually matter where this source is in the scene, because it's a sun-type source, so it's emitting completely collimated light everywhere in the scene with no actual source. So we can move this wherever we like, and the scene will look exactly the same. But just for convenience, let's keep it a bit up and out of the way of the actual lattice so that we can see what we're doing. Press Alt-Z to go back into object mode. Now, obviously, the scene we're seeing in the 3D viewport has nothing to do with this lighting, because this isn't actually a render, it's not interacting with the lighting engine at all. But if we go back to the render preview mode, you can see now that our atoms are lit from above, and they're throwing shadow onto the atoms at the bottom, so we actually have some active lighting in the scene. We can change the angle of the sun. If we click on this yellow spot and drag it around, you can change its angle in the scene. And you can also manually set the rotation here using these fields. So you can change it to whatever you like. I generally think that something at about 45 degrees, so we get this nice half shadowing, that is about right for lattices. Okay, but the atoms themselves, even though they're now lit, they look incredibly boring. They're just like matte grey shapes. So in order to change this, we need to add a material to these objects, which will change how they interact with the lighting engine. And again, we can't add the material directly to the atoms on the corners because these are all just instances of this atom. So we have to add the material here. In order to add a material, select the object where you want to add the material and go to the red and black sphere, which is the material properties. Again, you'll see that this is currently empty, so we can add a new material by pressing the plus. And we can tell it that we want a new material here by pressing the new material. If we wanted to select an existing material, you go to this drop-down menu here, and you can select any material that already exists in your project. That is project specific, so if you go to a new project, you won't have the materials from an old project unless you port in the folder. Okay, at the moment this is just called material 001. I'm going to call this atom, just so I remember what this material is for. And here we have a bunch of options for modifying this material. First of all, you'll notice here we have a drop-down menu called Preview. This allows us to just see how this object will actually render. So this is useful to have up while you're playing with properties. Below this, we have a surface drop-down menu. So there are two types of shaders in Blender. There are surface shaders and volume shaders. Surface shaders predictably affect how light interacts with a surface, while volume shaders determine how light will be modified as it moves through a bounded volume. In almost all cases, you will be using the surface shaders because that's what's used to make the majority of material effects. For some transparent objects or some emissive objects, you might end up using volume shaders, but in this project, we're not even going to touch that. By default, the surface shader is set to principled BSDF. This is a kind of workhorse shader that has a whole load of different options in and is suitable for making most objects. Okay, there's two very specific rendering options here. I've never actually changed either of these, so I don't think you'll need to either. The first option we're going to look at is the base color, because at the moment this is just like, well, it's white, but it's coming out gray in the scene, and we don't really want that. So if we click in base color, we can change this to any color that we like, green, yellow, red, anywhere on this color wheel. Okay, so let's say we'll have these a kind of cyan blue, like that. And you can enter colors as well as selecting them from the color wheel. Stay up, please. You can enter RGB values, HSV values, or you can directly insert hex codes if you like as well. Next, we have some subsurface scattering options. So subsurface scattering is a way of creating the illusion of volume and depth. When a ray of light hits a surface, if it's just interacting with the surface shader, then it just bounces off after acquiring some properties from that shader. If you have some subsurface scattering, then it simulates as if the ray was being absorbed in the surface to a certain depth and then scattering from within a certain depth of the surface. There's no real depth being added to the scene using the subsurface scattering. It's just simulating the effect of depth on the ray of light. So one of the most common reasons to use a subsurface scattering modifier, use subsurface scattering in a shader, is to create the effect of skin. You know, if you hold your hand up to a bright light, then you can see the faint red glow around the edges of your skin where light is coming through. So you can simulate that in Blender using subsurface scattering. In this case, we don't need it, so we're going to ignore it. And next we have a bunch of different options for affecting how the surface is mapped and how the light interacts with it. So for example, we can make this more metallic with this bar. Some of these properties are a bit redundant, some of them are conflicting. Really, you just need to experiment with them and see what gives you the effect that you want. So you can't break this by experimenting with it. So if we were to turn metallic up to maximum, you can see this now has a kind of metallic sheen on it. If we turn it down, it looks more matte. The specular reflection, you can see that we get the kind of specular spot on the surface on that basis, or we can make it look completely flat with no specular reflection at all. Generally, you always want some specular reflection. All objects in reality have some degree of specular reflection. Maybe Vanta Black doesn't, I don't know, but yeah, you almost always want to have some specular reflection. Specular tint, I think that just changes whether the specular reflection is colored or not, or whether it's white. Roughness changes whether you have all specular scattering, so if it looks like it has a perfect sheen, or if you have some diffuse scattering. And again, generally you want this to be somewhere in the middle. If you're creating something that you want to have a lacquered or varnished or glassy texture, then you want the roughness to be very low. Anisotropic values, I honestly don't know that much about what these do. I think the best thing here is just experiment with them, see if you find that it modifies the look in any way you're interested in. If I change this now, I don't think it will do anything. Sheen, I think that's redundant with roughness. This is starting to stretch my knowledge. Clear coat. So a clear coat, you can add a layer that has high specular reflection on top of an area that has low specular reflection. So you can see here that we've got both the spot of a really smooth surface on top of the more diffuse specular blob. So that's like creating the impression of having varnish over a surface, and that can be quite useful for mimicking things like varnish wood, where you have a combination of both diffuse and specular scattering. And you can make the clear coat rougher or smoother as well. Okay, so here we have 3 parameters which are important for transparent objects. So transmission is the transmissivity, so how much the light is able to go through the material. Now, this is not the same as having a volume shader. It's not actually simulating what's happening to the light as it moves through the volume. It's only simulating what happens to it at the boundaries. So if you have a very, very thin layer of something which you want to behave like glass, and you give it a transmission that's close to 1, and then you make that layer very, very thick, its optical properties will be quite similar because it's only simulating what's happening really at the surfaces. Whereas if you actually had a volume scattering shader, if you made that glass thin or thick, its optical properties would change significantly. Okay, but if we want to make something clear, we can run up the transmission and it will become clear. Except here, you might notice this doesn't look great. This does not look good at all. Yes, it sort of looks like one of those really rough marbles, or maybe one of those like rubber bouncy balls, but there's not really any transmission here. We're just getting a sort of rough scattering. So what's going on? Well, what's happened here is we've hit the limit of the rendering engine that we're using. So to change the rendering engine, go to the camera at the top of the menu, which is called Render Properties, and click on that. And you'll notice at the top here we have a render engine selected called Eevee. So Eevee is an engine that's used sometimes for video games or for previewing. It's a very low impact rendering engine that cuts out a lot of the functionality of proper ray tracing engines. It's selected by default in a new project because of its low footprint. But there are 2 other shaders in Blender. One of these is called Workbench. I have never used Workbench, and I don't really know what it's for. And I've never seen any 3D artists using Workbench either. I'm sure some do. Maybe someone knows what it's for, but I don't. The main one that you're going to actually use to make nice figures is Cycles. So Cycles is a full ray tracing engine. So when we're using the Cycles engine, where the beam of light is coming from our light source, hitting the object, and it's tracing its path through or around the object, depending on the material, to the camera. And it's very accurate. It can create incredibly realistic looking images, but it is quite high footprint because we're tracing thousands and thousands and thousands of light rays in every frame. So you can see that this, well, there are some aspects of this that don't look better. I'll get into that in a minute, but the lighting here looks much more realistic now. But you'll see if I pan around, I get this pixelation, and that's basically because it takes my graphics card a couple of seconds to fully render the frame. Okay, so I'm getting artifacts as I'm moving around. Now I'm running a NVIDIA 2070 Super, which is pretty good, and a Ryzen 7, an AMD Ryzen 7. So my render time is quite short. If you're running on older hardware, your render time could be tens of seconds up to a minute. Okay, so when you're doing project editing, you really don't want to be sitting in Cycles looking at your image because, yeah, it's going to get really confusing. You're going to get a lot of artifacts and your computer's going to slow down an awful lot. When you switch to cycles, you'll get a lot more options for the rendering engine than you had in Eevee. Most of them you won't need to edit, but one, if you have a dedicated graphics card, it's worth straight away switching to GPU compute. This will dramatically speed up your rendering and it will prevent Blender from crashing. If you're trying to render on your CPU as well as actually run the Blender program or whatever else you've got going on in the background on your CPU, you'll find things slow down really, really fast. Now I'm on my graphics card, this is really nice and fast. You can see it renders in a couple of seconds. Okay, one more point before I move on. You'll notice that there's a lot of this speckling going on now that we're in Eevee, in Cycles, which wasn't there in Eevee. This is, physically it's kind of similar to shot noise. It's basically where you have a ray of light that's come through and there's a problem averaging between all the different paths that it's getting, and it's throwing an error, and you're getting a bright spot in one specific place, and that's creating this speckle pattern. You almost always see this when you have translucent or transparent objects in your scene, because most of these errors occur when it's trying to map the actual refraction of the beam through the object. But fortunately, there's a couple of filters that we can apply to solve this. If you if in render properties you go to denoising and you click this menu, you'll see we have options for render and viewport. If we tick these, it'll take a little bit of time to load, especially when you're doing it the first time, so be wary of that. You might have just crashed your computer, and I'm sorry if you did. If you did and you come back, welcome back. Sorry I didn't warn you about that. Yeah, when you click on viewport, it will start adding a denoising function, and you have a couple of different options: automatic, optics, and open image denoise. Optics is by far the best, so select optics, and for render as well, use optics. Okay, and now you can see we still have some distortions here, but it's much better than it was, and in the final render it will be better still. Okay, so we can now see that these objects look more like transparent objects. You can see I've even got some nice focusing here of the light that I can see. But I'm not that pleased with this kind of cloudy marble look, so I'm going to go back to my material. You can see now I can see the Cycles preview rather than the Eevee preview. And I'm going to go down to my transmission properties. So I've got 100% transmission, so this should look like very clear glass. The reason it looks like this is because of its roughness. If I turn the roughness right down, now you've got something that looks more like a sort of perfect lens. And I can also modify the index of refraction from this menu, so I can make it something that's more like diamond, or I can make it something that's like almost like air, where there's basically no distortion, no refraction at all. Or I can make some crazy metamaterial. There we go. Ooh, cool. But generally I find, yeah, you want to stick close to the properties of standard fused silicon, because that looks most normal. Okay, so these kind of glass marbles, it's quite a cool image for the atoms, but to be honest, I think this is probably more trouble than it's worth. So I'm going to turn the transmission down, and I'm going to go back to the metallic mode instead. Now that the roughness is really low, I'm getting these crazy reflections, so I can see this image of the lattice at each point. I'm not sure I like that, so I'm just going to turn the roughness up a little bit more. There we go. I'm quite happy with that. Well, we've kind of got the reflection, but a little bit of this diffuse scattering as well. Okay, you can also make your objects actually emit light, so they can glow if you want, and you can use the alpha to make them go invisible if you wanted to do that. Okay, but I'm quite happy with this material, really. I think that's right for the atoms that I want to make. They're a bit dark, I think, possibly. There's maybe not quite enough lighting here. So I'm going to modify how strong the sunlight is. And to do this, I'm going to select my sun object in the hierarchy. And you can see here we have some different options. I can make the sunlight a different color if I want to. If you change it and you want it to go back to normal, you can just change it in the HSV. There we go. But you can see its strength is only 1. I think that corresponds to 1 watt by default, I think. Oh, it's watts per meter squared. There we go. So I want this to be a bit stronger, really. So I'm going to drag this to turn up the strength. Okay, that's stopping me at 10, but you can't go higher than that. 100, that's maybe a bit bright. Let's call it 50. I like that. I think that looks good. You can see I'm getting tons of this noise around the reflections. That can be a problem, which we'll have to fix in the render. Okay, these atoms look good. I'm happy with the material, so now I'm going to hide my main collection again, and now I have my simple cubic lattice. Okay, so now it's time to try to render, right? So the problem at the moment is that I don't have a camera in the scene that can perform the render, so I need to add one. So again, Shift A, and I'm going to go to Camera. Okay, and this creates a new camera at the origin. I don't want it at the origin, so I'm going to press GZ to move it up, and then GX, and I'm going to move it back. So it's now kind of looking down diagonally on my simple cubic unit cell. This square here, this is the front of the camera, that's the viewport. And you can imagine this point here, that's the focal point for the camera. Okay, so if I want to know what the camera is actually going to look like, I can kind of try and line things up with the camera view, but this is a bit kind of coarse. So I can align my view directly to the camera if I go to View, Viewpoint, and then Camera. And now I'm looking straight down the camera. I can also use the shortcut there of pressing 0 on the numpad. So the highlighted rectangle here, that's what the camera's actually going to see when it renders. Okay, so at the moment we're not catching the whole unit cell. It's not in the right position. Now what I can do is I can try and use the G move commands, and I can try to move it around like this, but you know, that can get a bit tricky to line up. So instead what I'm going to do is I'm going to go to the End menu over on the right. I'm going to select View, and I'm going to select this option to lock the camera to my view. And now if I use the standard mouse controls to move the 3D viewport around, you can see the camera moves with it. Okay, so now I'm going to pick a position in space that I want to view my unit cell. So that is about right. That means that we're pretty much centered, and I can center it by selecting it and pressing full stop on the numpad to center the view, and then the camera will come with it. So that's centered in the view, and I'm getting some nice reflections, and I can see the lattice reflection, so I think that's nice. I'm going to keep it there. So remember then to untick locking camera to the view if you want to then move around, otherwise you're going to drag your camera out of position. Okay, so now we're ready to do a render of this scene. So to do a render, go to the render menu at on the top bar, and from the drop down, click Render Image. Alternatively, you can just hit F12. Okay, and now we get a render window. And there we go. That was pretty fast for me because of the 2070 Super. It might be slower for you, or it might be faster. Maybe you have a 2080 Super. Maybe you were smart and you waited to get the 3080 Ti and you're running 5 times faster than me, although if I understand the news correctly, it might have broken. So maybe that was bad luck. I don't know. Anyway, right, back to Blender. We have our atoms in the scene. You can see around these reflections that there's still a bit of a coarseness. The optics noise cancellation has smoothed it out, but it doesn't look perfect. There's a whole bunch else wrong with this. For a start, it has this horrible grey background. We don't want that. If you put that into lecture slides or into a talk, it's going to be surrounded by this really dark, boring grey. We don't want that as a background. And also, it looks kind of weird where we just have these atoms floating in space. Might be better to have like a ball and stick model where you can see the bonds. Maybe that would be good. So let's just get rid of that. That's useless. Okay, first things first. Let's talk about this background, because we don't want this grey background in all of our images. It doesn't look nice. Now, of course, we could try to add objects into the background, like a white wall or something, to make it look nicer. In almost every case where I'm doing renders for talks, I don't want any background because I want to be able to layer it over other things that are in my slides. So in order to change that, you need to go back to the render properties and you need to look at film. Okay, so this is basically what it says. It's the film, the virtual film that the image is being projected onto. And we can change a whole bunch of things about the film. I'm sure if you're a photographer, you could have a field day with all this. But all that we want to do is change this to transparent. And now you'll see we have an alpha grid in the background that's telling us that that background won't be there in the final render. And if I now hit F12, you will see that my atoms are floating against a transparent background. It's important that that will only happen if you're exporting to a format that supports transparency. So if it has an alpha channel, like a PNG, for example. But if you're trying to render and you're finding that your transparent background is black or white or whatever the default color is for that format, it's because you're in a format that doesn't support an alpha channel. Okay, that's point one. The next point, I don't like the fact that these atoms are just floating in space. I want them to be connected together. So fortunately, there's a really easy way for me to do that, again, using this cube that I've put into the scene, because I can take all of those edges and I can turn them into meshes that are going to be rendered in my scene. And the way I do this is, again, using a modifier. So if you click on the cube, select it so it's highlighted orange, then go to the modifier properties, you will see our particle settings one that we already added to the system before. But we want a new modifier, and the one we want is the skin. Okay, what this does is it takes any edge, any line in Blender, and it transforms it into a 3D mesh. Okay, so we're going to select skin. Whoa, okay, right, that is not what we want. So these are far too blocky and they're far too big. And you'll notice here that there are no options to change this size. It looks like we're stuck. And for ages, for months, when I started using this, I thought I had to create every stick, every bond that I wanted in a ball and stick model individually, because the skin modifier didn't seem to work. And I figured out what was actually going on, and now I'm passing it on to you, so hopefully I'll have done some good in this tutorial. What determines the size of this skinning is every vertex point has a radius associated with it that defines the size that it's representing in space. Okay, in order to access and modify that radius, you need to select the object that you're editing, press Tab to go into edit mode, press Alt-Z so you can actually see the mesh, and then in vertex mode, select one of those meshes and then vertices, and then press A so that you select all. And now, can you see that there is this dotted ring around this one? This is the origin vertex. Okay, so this defines the starting point of the mesh. Okay, you can see there's this dotted ring that represents this radius. Okay, so if we go to item now, you can see that we have vertices data and we have a radius in X and Y, which is currently 0.25 meters, which is way too big. So if I drop this down, say 0.05, and you can see now that this is much thinner in X. Change it here and it's now much thinner in Y. That now looks much more like a ball and stick model. Okay, that looks much better. Press Tab to go back into object mode, and you can see that now all of our atoms are connected by these rods. But you'll notice that these rods are very square looking, which is not ideal. I can go to shade smooth, but that doesn't really accomplish very much because the geometry is incredibly limited, so it doesn't really help. So how can I make these better? Well, one of the interesting things that you can do in Blender is you can stack modifiers on top of each other and they'll have different effects based on how you stack them. So because we've put a oh yeah, sorry, I forgot. You can also make them smoothly shaded here, which is the same problem. It's the geometry is too limited. So if I go to my modifiers, I can add a subdivision surface on top of the skin modifier. And then even though the skin modifier is already adding a modification to the geometry, changing it into this 3D mesh, the subdivision modifier will be added on top of that, so it'll apply a subdivision surface to the surface that the modifier has created. If I were to drag the subdivision modifier so it's before the skin, then I'd get a completely different result, because now what's happening is the subdivision surface is being applied to the cube, and then the skin is being added on top of that, so now it still looks blocky. Okay, so this is just showing you how this set of modifiers, this is almost like a program that you're running. You're running one operation after the other, and the order is important. I've just noticed I'm in the way. Okay, so now we've added a subdivision surface. You can see that we're now, we've broken down that square surface into a few smaller components, and in the viewport we can make that even smaller. That now looks a million times better, but we've still got this slightly blocky texture, so I'm now going to tick the smooth shading in the skin modifier, and voila, we now have a lovely cylindrical bond, and we haven't actually had to create a cylinder or move it around or do anything. We've just been adding modifiers to this simple cube. Great. So I'm now pretty happy with that shape. I think that looks good. I like the material and I like the bonds. I think that looks like a simple cubic unit cell. So let's do another test render. Let's see how that goes. There we go, finished. So now I can click on image and save this. I'm going to save over test 2. And now if I open this, there we are. So that looks fantastic. There's a tiny little bit of aliasing on some of these edges, which maybe could be improved with more time, but I'm pretty happy with that. I think that looks good. So hopefully if you've been following along with this, you've also got a nice looking simple cubic unit cell. Hopefully you've learnt the basics about how to use Blender's 3D workspace and how to make simple projects. And I hope you will come back for part 2, when we'll be looking at some more complex geometries and how to use arrays. So thanks very much.